All right, let's jump straight into this explainer. Today, we're looking at how Slack secured a massive infrastructure upgrade when they made the leap to HTTP/3. This is honestly just a fascinating look at what happens when a global communications giant modernizes its core protocols, hits a massive brick wall, and then engineers a fix that ends up benefiting the entire open source community. If you've ever wrangled a major infrastructure migration, you know they are, well, rarely smooth. But how Slack handled this specific roadblock, it's an absolute masterclass in creative engineering.
So let's start with a genuinely terrifying operational blind spot. Imagine losing your client-side visibility right in the middle of a major protocol rollout. You're running a service used by millions concurrently, you're pushing HTTP/3 to the edge to squeeze out better performance and lower latency, and then, bam, you realize you literally can't see how your new network is performing. It's kind of like flying a commercial jet with a blindfold on.
Now, what's really wild here is the stark contrast between their legacy TCP-based tools and the new UDP-based realities of HTTP/3. Slack had been relying on this hybrid mix of commercial SaaS tools and internal custom solutions. And hey, those were perfectly fine for monitoring standard traditional TCP traffic, like HTTP2. But HTTP/3? It completely breaks that paradigm because it ditches TCP entirely. When Slack flipped that switch, they were suddenly staring at zero visibility with their existing toolkit.
And as you probably know, to understand why that happened, we just have to look at the underlying tech. HTTP/3 is built on the Quick Transport Protocol, which uses UDP instead of TCP. Because of that fundamental shift, literally none of Slack's SaaS observability tools could probe HTTP/3 out of the box. And honestly, the biggest kicker? Their internal Prometheus Blackbox Exporter, which was essentially the bedrock of their monitoring setup, had zero native support for Quick.
So, the stakes here. We are talking about Slack suddenly being unable to probe hundreds of thousands of HTTP/3 endpoints across their shiny new infrastructure. Think about that scale for a second. Hundreds of thousands of endpoints, totally in the dark. Without this capability, the engineering team couldn't check for regressions back to HTTP2, and they couldn't grab accurate round-trip measurements. I mean, you simply can't run a reliable enterprise service if you can't even measure its baseline health, right?
All right, Section 1. Enter the intern.
Let's look at Sebastian Feliciano's quest to solve this. His approach breaks down into three really smart architectural choices. First up, picking a rock-solid HTTP client foundation. Second, making sure the new build played nicely with existing tools. And third, figuring out how to actually deploy the whole thing within the super tight timeline of a summer internship. Let's walk through these.
For step 1, he went with quic-go to serve as the HTTP client foundation for the new Prometheus functionality. And this wasn't just a random dart throw. quic-go has huge adoption across other open source projects, and it offers first-class support for spinning up HTTP clients in Go. Basically, it gave him the exact bedrock he needed to start firing probes over UDP. Step 2 brilliantly shows his commitment to composability. You know, it's one thing to just hack together a local script that gets the job done, but it is a totally different beast to engineer a feature that drops seamlessly into a massive open source tool like the Prometheus Blackbox Exporter. By sticking strictly to the exporter's existing architecture and configuration patterns, Sebastian basically guaranteed community buy-in. It's just smart engineering.
But of course, there's a twist. Sebastian hit a very real, very human roadblock. We all love open source, but let's be real. Maintainers of major projects don't exactly merge pull requests overnight, especially for completely new protocol features. And remember, Sebastian was an intern. His clock at Slack was ticking. He literally didn't have the luxury of waiting weeks or maybe months for the community to review and merge his code. So instead of just twiddling his thumbs waiting for upstream merges, he pivoted. Waiting was just too slow. He architected this really clever in-house integration to bypass the wait entirely, utilizing the new upstream features he'd built so Slack could start probing those HTTP/3 endpoints immediately. He unblocked the company's critical migration without having to rely on external timelines.
Moving on to Section 2, the open source solution.
Internally, the operational wins were instant. Slack finally had that coveted single pane of glass. Right there in their Grafana dashboards, they had a unified side-by-side view of HTTP/1.1, HTTP/2, and HTTP/3 metrics. This meant far more reliable alerting for the new endpoints. And because all that telemetry data was finally living in one place, engineers could correlate metrics and debug network hiccups way faster.
But the win didn't stop internally. Beyond patching up Slack's own blind spots, Sebastian and the team successfully open-sourced that quick support for the entire Prometheus Blackbox Exporter community. They essentially handed a free, out-of-the-box solution to any org looking to adopt HTTP/3. By plugging this gap, Slack helped future-proof observability for literally everyone moving toward quic.
Section 3. 3 key takeaways.
So what should we actually internalize from this? This explainer synthesizes 3 concrete maxims. Number 1, monitor first, migrate second. Getting your observability locked in before you shift traffic just makes everything infinitely safer. Number 2, contributing to open source pays major dividends. When you fill a gap in a technology like quic, the whole industry wins, and your own company reaps the benefits of long-term support. And finally, number 3.
Bet on your interns. I absolutely love this takeaway. Giving a proactive intern the trust and runway to solve a huge problem literally pushed Slack's vital QIC migration across the finish line. Sebastian's creative problem-solving didn't just give Slack a working black box monitor, it solved a massive headache that enterprise vendors hadn't even figured out yet. It's just a killer reminder that game-changing solutions can come from anywhere in your org chart.
Okay, last up, Section 4, the future of probing.
Looking ahead, Slack's infrastructure team is eyeing 2 advanced probing features. First, server name indication, or SNI, routing tests. This basically validates that edge infrastructure is handling SNI extensions correctly, making sure traffic requesting a specific hostname over a shared IP actually hits the right backend, which prevents messy misrouting errors. Second, they're exploring end-to-end path visualization. This takes things way beyond basic up or down checks by visually mapping the network hop by hop. That lets you pinpoint the exact physical location of packet loss or latency spikes.
So, I'll leave you with this to chew on. The web is undeniably moving to HTTP/3 and quic, prioritizing speed and efficiency over UDP. But as these new protocols become the absolute industry standard, are you absolutely sure your own infrastructure observability isn't being left in the dark? Slack found out the hard way, but thanks to an intern's hustle and a commitment to open source, they built a flashlight for the rest of us. Make sure you use it.